on this, you're going to have an area for the second figure that is twice the area of the first figure. So if you make your dimensions x and y for the first figure, you can go over to the second one and make it 2y and x. The rule for a rectangle when you're increasing the area is that if you double one side, you're going to double the area. So that's why we made this 2y. The x would stay the same, and you would end up with a perimeter for the first one of 2x plus 2y, and for the second one 4y plus 2x. And of course, if you add those both together, you'll have 4y plus 6x for the perimeter. And for the area, the first one is xy and the second one is 2xy. If you add those both together, you get the area. Now you have to set the perimeter equal to 4,000. That's how much fencing you have. And solve for y to get this. And then once you have that, you plug it back in. This expression here for y, plug it in this spot and this one. Here it is here and there. And then go back and simplify that, dwindle it down to 2000x minus 2x squared. And then go through and find the derivative. And set it equal to 0. And you come out with x is 500. And of course, do the second derivative test. You can see that it's negative, so we found a maximum there. So we're maximizing the area. And then here's the perimeter, and you go back in and plug in that 500 for x into the perimeter and solve out for 333 1/3. Anytime you can come out with a fraction that's neat, like 0.3 repeating, 0.6 repeating, and any number repeating, like 0.1 up through 0.9, because then you're going to have, it's going to be something over 9 as a fraction. If it's 0.75, it's 3/4. Just turn them into fractions. Then go back and test your dimensions. If you find the area of this and the area of this, you'll find that this area is twice this one. Alright, so you have a cylinder and the top is open. The volume is 1,000 cubic feet. Now, the volume is going to be, with a radius of x, pi x squared times y. I made y the height. So you can solve that formula down later. I actually put it over here. This is just work that I brought up from the bottom. But here's the formula for volume. And for surface area, notice you only have the bottom. You don't have a top. So the area of a circle is pi x squared, and then plus the surface area around the can. It's kind of like a soup can label. You peel it off, and it's what shape? A rectangle. So you need a length times width. We'll let this y be one of them, which is right here, and then of course you need the distance of, or the length of that rectangle, and that's going to be equivalent to the circumference of the base or the height, or the bottom or the top. So 2 pi r is the formula for circumference, so we're using x, so that's why it's 2 pi x. And with that, you can dwindle this one down for y from here. The volume formula is what I'm using to solve for y. And that comes out to be 1,000 over pi x squared. You're going to plug that back into the surface area formula just in that one spot where the 1y shows up. There it is. And then simplify it and find the derivative. Remember to go from here to here for a derivative. When you have the variable in the denominator, you increase the variable by 1, change the sign out front, and move the old exponent up to the top and multiply. Of course, the old exponent was 1, so 1 times 2,000 is 2,000. There's the sign change, and there's the x squared. Set it equal to 0, and when you do that, you can do all kinds of multiplications, and it doesn't change the other side. So I multiplied through by x squared to eliminate the x squared in the bottom. When you do that, this is what you're left with here. And then solve for x. When you do that, you'll come out with 6.8278. 6.8278. Here's the second derivative test, plugging it in. It's going to come out positive. I don't think we need to see all of the work for that, but we must make note that we did it. And once you have x, you can plug it back in up here in this spot, square it, multiply it by pi, not 3.14, use the pi button on the calculator, 3.14159 and on out, and you'll come back with 6.8279. For today, to use calculus to solve optimization problems, again, there's several different ones we can do, and we'll spend time on a few different types. Here's the first example. A cylinder has a volume of 8,000 cubic feet. This will be similar to the one we had last night, except it will have a top to it. Volume of 8,000 cubic feet. What dimensions will allow the cylinder to be built using the least amount of materials? We want a cylinder to have 8,000 cubic feet, but we don't want to spend all of our money on unnecessary materials, having a 4-mile long tube that's only about a ½ inch in diameter. So here's the cylinder, and you have a radius there, and it does have a top. Last night's homework did not have a top. So we're going to make the radius x, and we'll make the height y. So the first question is, what is the formula for the volume of a cylinder? So we'll have volume equals pi x squared times y. We'll use the variables we have in there. So what is the formula for the surface area with relation to x and y? So your surface area should be 2 pi x squared plus 2 pi xy. And remember, the first half is the top and the bottom area of the circles, and the second half you're adding is the area of the soup can label object. When you unroll it, it's a rectangle. The 2 pi x is the circumference of one of the top or the bottom. And then the y is the height of the cylinder, which is essentially the width of the triangle or the rectangle. Alright, so we have our two formulas up at the top, so now you have to set pi x squared y, which is the volume, equal to 8,000 and solve for y, so we can have something to plug back into the surface area formula. So go ahead and set that up. Pi x squared y, and set it equal to 8,000, and start solving for it. So if you're going to set it up, here it is. And then your first step is to get y by itself and divide 8,000 by pi x squared. And then your movement from there is going to have to be to sub that into the surface area formula for y. And y shows up in one spot on the surface area formula at the end of it. So there at the bottom we have the surface area formula, and it's the same except at the very end you've put in 8,000 over pi x squared. But notice that it's attached by multiplication to the 2 pi x. So you have to multiply 8,000 by 2 to get 16,000. Notice you have pi over pi, so they're gone. And you also have x over x squared. So that means you're just left with an x on the bottom. The one on the top cancels out. Alright, your next step is going to have to be to find the derivative of the surface area function. So we start off with the surface area function being 2 pi x squared plus 16,000 over x. You need the derivative. So on the first part you end up with 4 pi x, but don't forget you have a variable in the denominator on the back end, which means you add 1 to the exponent, change the sign out front of it, and move the old variable to the top, which in this case was a 1, and multiply it by 16,000, which means we still have 16,000 there. So 4 pi x minus 16,000 over x squared is the first derivative. We have to set that equal to 0. So when we set it equal to 0, it's going to look like this. And now since it's equal to 0, we have some options available as far as multiplying through and making things easier. Let's get rid of the x squared on the bottom of that fraction. You can multiply both sides by x squared so that we can cancel out the x squared on the bottom. So when you do that, you have 4 pi x cubed minus 16,000. The x squared cancels out here. And all of that equal to 0. So now we have to solve this equation. So we move the 16,000 over to the right, make it plus 16,000. And then from there, divide by 4 pi. And when you do that, you're left with 4,000 over pi, and then the cube root of that is going to be 10.8385. Finding the second derivative now. Here is the first derivative, 4 pi x minus 16,000 over x squared. And the second derivative, remember, you increase the exponent on the denominator variable by 1, move the old variable, which is 2, to the top and multiply by 16,000. That's where we get 32,000. And change the sign out front. Now we have the second derivative, 4 pi plus 32,000 over x cubed, and insert 10.8385 into the second derivative. So there's the second derivative, and we're going to insert that into the function, 10.8385 that is. And when you do that, you're going to come up with a value that is simply positive. That's all we're interested in. So since it's positive, it means that the 10.8385 is what kind of value? It's a minimum. That's right, because we're looking for minimum material. So we're going to have an x that is 10.8385 in order to have the minimum materials we can have. It's the lowest radius that we can have. So since the second derivative is positive, of course, we're going to have a minimum. And insert that 10.8385 into pi x squared y equals 8,000. That's the formula for volume. And we're going to solve for y in that case. So inserting the 10.8385, divide 8,000 by pi times 10.8385 squared, and come up with a value of 21.6771. Final answers are 10.8385, and the height is 21.6771. A cylinder has a volume of 6,400 cubic feet. What dimensions will allow it to be built with the least materials?